Without our global stabilizer, our axis could vary between 0 and 90 degrees. This would alter the distribution of sunlight across the surface of the planet, devastating our finely balanced weather systems. Climate patterns would go berserk. The tropics could find themselves frozen under ice, and Antarctica transformed into a vast desert. But luckily, the moon saves us from such disasters and allows life to exist.
It turns out that it may have had a really profound influence on how life has originated and evolved on the Earth. In fact, you might almost be able to argue that we wouldn't be here today filming this if the moon weren't up in the sky.
Not all planets in our solar system are so lucky. Mars has 2 moons, but they are too small to stabilize its tilt. As a result, the red planet rolls much more than Earth. Some scientists believe that this is one of the reasons that there is no life there now. When you look at our moon today, the first things you notice are the craters. They tell astrophysicists, such as David Kring, about a distant and violent past.
You can look up from your own backyard and see impact craters on the lunar surface. There are over 300,000 craters, half a mile to over 500 miles in diameter on the lunar surface.
Most of these craters come from meteorites hitting the moon. The largest crater you can see from our planet is the Imbrium Basin. It is 700 miles across. Moon craters come in various sizes, but almost all were created at around the same time. Around 4 billion years ago, a chance alignment of the gas giants Jupiter and Saturn changes the shape of their orbits. This creates a slingshot effect, hurling asteroids toward the inner solar system, straight at Earth and the young moon. For millions of years, asteroids bombard the entire inner solar system.
Some of these impact events would have produced impact craters the size of continents or larger. These type of impact events have the capacity to obliterate any oceans on the surface of the planet and superheat the atmospheres. Life as we know it could not persist on the surface of the Earth.
This period of intense bombardment is called the lunar cataclysm. The Earth's gravity makes it worse, pulling meteorites and asteroids directly toward itself. On its own, the tiny moon might have escaped with less damage, but it's too close to Earth. Asteroids heading for impact with Earth hit the moon instead. The moon becomes the first victim of collateral damage. Most of the craters on the moon formed during the lunar cataclysm. 80% of the lunar surface is destroyed. Molten basalt oozes from fissures and fills impact craters, creating seas of lava. Over millions of years, these will cool, solidify, and turn into maria, or seas, such as the Sea of Tranquility. It is the pattern of dark basalt rock that creates the face of the man in the moon, as we know it today. David Kring demonstrates exactly what happens to the surface of the moon when a meteorite strikes. He releases a 5-pound rock from 50 feet above a sand pit. On impact, sand is fired upwards into the air. During the lunar cataclysm, some impacts are so big that material fired upwards never returns to the moon's surface. Instead, it is propelled into space, where it is trapped by the gravity of the Earth, still only 86,000 miles away. Some of these rocks hurtled toward our planet.
You actually would have seen a huge plume of debris rise up off the lunar surface. This cloud, in fact, would have enveloped the entire lunar surface, and out of that cloud there would have been fragments of rock that pelted the Earth. They would have streamed through the atmosphere as intense fireballs to land rocky components on the Earth's surface.
These lunar meteorites are incredibly rare. This is part of one of only 30 lunar meteorites ever found.
So this is a sample that fell in Africa. Analyses of samples like this tell us that there was a cataclysmic spike in the number of impact events that affected the moon 3.9 to 4 billion years ago.
Lunar meteorites contain a record of the geological history of the inner solar system as it was around 4 billion years ago. These rocks are older than the oldest rocks on Earth. The existence of lunar meteorites on Earth started scientists wondering if rocks can be catapulted from the moon to Earth. Could rocks from the Earth also reach the moon? And if such Earth meteorites could be found, might they hold fascinating clues to what was happening on Earth billions of years ago? To blast anything free from Earth's strong gravity requires immense force. Far more power than it takes to launch a lunar meteorite off the surface of the moon. For example, the space shuttle uses 15 million horsepower to escape from Earth's gravity. The lunar module needed just 6,300 horsepower to lift off from the moon. But just how big an impact would it take to blast debris off of the Earth? Award-winning astrophysicist Guillermo Gonzalez from Iowa State University has figured out the answer to that question.
The crater in northern Arizona, meteor crater, even that, which is really big when you go right up to it, wasn't large enough to catapult any significant amount of material beyond Earth's atmosphere. But when you're talking about, say, the crater that killed the dinosaurs in Mexico, now that one was probably big enough to start launching some at least small amount of material beyond the Earth and have some of it land on the moon.
Impacts on Earth during the lunar cataclysm are far bigger than the dinosaur extinction event. They impact with such power that they punch holes in the Earth's atmosphere. Rocks and debris thrown skywards escape through these holes. Once in space, some of the debris is vacuumed up by the moon, orbiting just 86,000 miles away.
And it eventually makes its way to the moon, where it lands. And then when it lands on the moon, of course, it could be further broken up into smaller pieces depending on how fast it hits the surface.
Landing on the lunar surface, they remain perfectly preserved in the vacuum of space.
The early Earth, unfortunately, erased its early history, but it left a record of it, at least a partial record of itself, on the moon. And if we can find some fossils or at least remnants of early life in these Earth rocks on the moon, that can help us answer these difficult questions about the origin of life.
Gonzalez believes that more than 1,000 pounds of Earth rock could be spread over every square mile of the moon's surface.
It's the only place in the solar system that we can go to learn about the origin of life, because once the Earth rocks get to the moon, they're preserved there in a pristine form. There's no water cycle on the moon, there's no more active geology, and they get buried relatively quickly from the material from other impacts on the moon. And so they're preserved from the solar wind and other things as well.
So far, no Earth rocks have been found on the moon. Gonzalez will have to wait until the next moon mission, in the hope that these priceless rocks may then be discovered. The first half-billion years of the moon's journey from Earth has been a violent one. Over the next billion years, the moon continues its escape from Earth and out into space. Its passage changes the face of our planet beyond all recognition. The power of its gravity creates tides thousands of feet high, stirring up the oceans of the Earth. This creates the conditions for complex chemical compounds to form. The moon is aiding the creation of life on Earth. 3 billion years ago, the moon is still escaping from the Earth, and it now orbits almost 200,000 miles away. The effect of its gravity is weaker, but it still has the power to radically change our planet. For now, the Earth has water and oceans, and the moon is stirring things up. It's too far away to have a dramatic effect on the rocks of the Earth, but the moon is affecting the oceans. As the moon passes overhead, its gravity creates tides in the water. But these are not like the tides of today. These are thousands of feet high. Astronomer Neil Cummins studies how the early moon affected the tides.
When the moon first formed, the tides were something like 1,000 times higher than they are today. They would have gone inland as a wall of water, 10,000 feet high as a huge mountain. They probably would have covered hundreds of miles. And then they would come back, scouring the land, taking debris from the surface of the Earth into the oceans.
The material sucked into the seas contains minerals and nutrients. The tides created by the moon churn these into the most crucial cocktail in the history of Earth, the primordial soup. Different combinations of minerals are bound together and torn apart. It's in this violent melting pot that the right combination of minerals is forged into life. Cummins believes that the spark of life might never have occurred without the moon's power to churn up the primordial soup.
The moon created those tremendously high tides back when it first formed that allowed the oceans to fill with minerals, that allowed life to evolve, that allowed us to be here.
The tides may have even helped the first DNA to evolve. Some scientists believe that the changes in chemical concentrations when the tides go in and out cause the DNA to split and replicate. The enormous moon-induced tides have a further vital role to play in the history of the Earth. They help the whole atmosphere of the planet to calm down and become a more hospitable place in which more complex life can evolve. In our look back to 3 billion years ago, the Earth is a very different place. The impact that creates the moon sets the Earth spinning faster. It spins so much faster than it does now that a day lasts just 6 hours. This high-speed spin has devastating effects right around the Earth. The rotation of our planet is one of the most influential factors determining global climate. The spin of the planet creates winds and vortices in the atmosphere. The faster the spin, the faster and more violent the winds. Billions of years ago, when our planet rotated 4 times faster, the atmosphere whips over the land.
When a hurricane occurs today, 100-mile-an-hour winds, trees are blown over, houses lose their roofs, tremendous amount of flooding. But in a day or two, it's gone. Things settle back to normal, people get on with their lives. Imagine if we lived on a world in which those kinds of winds were continuous.
This